Okay, good afternoon. Late afternoon for everybody. Thank you, the organizers, thank you, Jose Carlos and Sabrina, for your invitation. We will try to bring you now from experimental work more to the large-scale field work, and using the eruption, the volcanic eruption in the Hierro Island. That's the top. Our center is working with biodiversity, conservation, and also interaction with human activities, tourism, geographic settings, and spatial planning, and law. So our main groups are biodiversity conservation, environmental chemistry, and quality of a chemical environment, mainly in the marine water, but we have a deal or some cooperation with different teams inside the university or with other teams, for example, here in La Laguna University. Just a very quick, this is the Canary Island without water. You see the insular building of the different islands. They are all volcanic. Only the Fuerteventura and Lanzarote, stopping the pointer, here in the east side used to be one big island. Now there are 2 or 3 even small island in the north. And Hierro is the youngest one, 1 million years old. And last year, since the summer of last year, here we are, La Laguna, and this place here is the last volcanic eruption. We have some bathymetric topography of the area in 88, and then in October last year there were several crews by different ship expedition. They have the volcano were growing from 10th of October, I guess, was the starting of the eruption. And the volcano was constructing, and they have some landslide later. And finally, until the end of March, or at the beginning of March this year, the volcano was active. These are some data about the pH and salinity, temperature in the area. There are very nice pictures all around the world, and they were showing the satellite vision of the area. This data here are giving you numbers about especially about the pH. We are talking about acidification several times these days. So in the volcanic site, just there, 100 meter depth, the pH is maybe around 5. If they dilute later and merge with the other seawater, so the combine gets a higher pH. But even though it's higher, but it's not 8.1 or 8.5, that is usually 8.3, sorry, that is usually the average here in this area. The temperature and other parameters are also changing. And let's see what happened with the marine biota. That was during the first event. There were massive fish mortality, also some invertebrates, changes in the area. Here you see the volcanic activity. The volcano was here, 100 meter depth, so 150 meter depth at that time. This is La Restinga. You're going to dive there next Saturday, something? Tomorrow? Okay, that's good. So this was 2 miles from the area. We did some sampling in 3 different periods. We used, let's say, a gradient process with samples near the volcano, to station 1, the closer inside the harbor, Restinga, outside the harbor, facing the northeast trade winds, Charco Manso in the north, and Arena Blancas in the other side. When we set up the network of the sampling station, we didn't realize the CO2 distribution pattern in the island, in the seawater of the island. But after discussing with the oceanographers, the setting was quite good. I will explain you why later. And then also we have a control station in southern part of Gran Canaria, and Canaria is here. This is the control station with more or less similar situation and similar marine vegetation in that control station. In November, March, and July, we did several samplings in the area, and with multi-parameter sampling, we got some data about this is the pH here inside the harbor, 7.5, 7.8. Outside here, the green star is about 8. Arenas Blancas here is just 8, more or less. And again, Charco Manso in the north is 8.1 or 8.2. So more or less, these two greens are more similar than these two reds are more similar in pH. The later months, the situation was more or less the same with Harbor and Arenas Blancas lower pH and higher pH in the other two places. And I have to mention that during the sampling period, the volcanic activity was 2 miles away from the shore. So we didn't have really a direct impact of material coming from the volcano in the shore ecosystem. That happened twice or 3 times in October and November, like waves coming, like a tsunami somehow, came and retreat. So the star will denote the places affected by the volcano activity, non-affected by the volcanic activity, lower pH over there, higher pH, well, normal pH, standard pH. And we use this is Spadina pavonica, it's a brown algae, calcified, so it's not very palatable for herbivore, not for sea urchin, not for other herbivores. But you could see quite clearly the difference in the field. So we start to do some measurements. Before that, this is also some crustose algae, the same situation. Those crows were dead, and these are quite healthy in the north and near the volcano area. Those were the data from we took a number of samples, and with a microscope, we measured the surface covered by the calcification layer in the seaweed. And this is the control area in Gran Canaria, north of El Hierro, Arenas Blancas, La Restinga, and inside the harbor of La Restinga, very close or more affected by the low pH events in the coastal area. So almost 90% of the surface of the algae were uncovered, without decalcified, without calcium carbonate. So that was quite clear. We did several months later, and in July again. The end of the volcanic activity was at the beginning of March. And the solid bars are the trend I showed you before. Very high decalcification in the harbor, and the increasing calcification or decreasing decalcification in the other areas. But after the volcano activity, most of the plants, most of the brown algae have been recovering or rebuilding the calcification layer. Aside from the calcification, we did some inside measurement with a diving pan, and we used to take some RTA curves with electron transfer, and the behavior of the Padina was much more affected, the physiological activity. This is part of another thesis of one of our students. Probably you will hear about holoturians. Here are one of the samples we took that day. Some limpets also quite affected. Fortunately, we have some samples from the same area and from the same location from previous years, so we can compare now situation well before the eruption, during the eruption, and after the eruption. For example, this just to show you, to give you an impression, these are fish community in the area. Just in November, in the lower picture, half an hour in the water, 3 fishes in total. After that, it has been recovering, and now you can, well, you will dive tomorrow, you will see much more marine life. But at that time, that was more or less a desert with very few animal life around. So this is what you could see from the satellites. The volcano was here, and sometimes these materials were even arriving to that corner here in Arenas Blancas, and that's probably one explanation for the reduction in calcification process here also in Las Arenas Blancas. These have lower pH than here on the other side. So the coastal oceanographic behavior is also important in this process. So somehow this volcanic eruption was a temporary episode. It's already gone. We may have another volcano, I don't know, maybe in 10 years or 20 years. Usually in Canary it's about 40 years period for a volcano, so we may see another one, I don't know. I hope so. But they give you let's say, a scenario about how acidification process can affect marine communities. In this sense, there was a clear gradient in the pH from the focal point, from the starting point of the volcano towards other direction, and depending on the currents, the oceanic current, you can have more affected or less affected coastal area. It was clearly a clear signal, this calcification process in the surface of the Padina, but also after the volcano stopped, after the pH was recovering to a more regular levels, the physiological performance and the calcification process of the algae is already recovering quite fast. That's more or less the other part, and probably we can use these episode events to mimic somehow. It's a really large scale experiment. Mimic how it could be the future scenario of IPCC, and that's more or less the idea. We wanted to, some of the preliminary results we are doing in this volcano activity. Thank you for your attention. Oh, sorry. I forget. I always want to go. These are part of the team that were in that one of the first expedition, and then we have to change it, different other people. Okay, that's it. Now it's finished. Hombre.